Welcome to all our viewers in India and around the world. You are watching Defense Dynamics and I'm Danveer Singh coming to you from New Delhi. On Defense Dynamics today, we'll talk about India developing Railgun, a gun that relies on physics and not explosives. Next, we'll tell you what exactly is Drishti-10 and why does it matter so much for India's maritime security. In a big development, India has successfully conducted a long-duration ground test of an actively cooled Scramjet full-scale combustor. What was this test all about? And why does it matter so much? We'll explain. In the end, we'll also explain why Pakistan is pushing the JF-17 to the Islamic world. But first, the global defense headlines.
At the annual Army Day press conference in New Delhi, Indian Army Chief General Upendra Dwivedi said that Operation Sindoor is still ongoing and any future misadventure will be met with a decisive response. On the security front, General Upendra Dwivedi said situation along the Western Front and in Jammu and Kashmir remains sensitive but firmly under control.
As you may be aware, Operation Sindoor remains ongoing. Any future misadventure will be resolutely responded to. Here I must acknowledge the proactive role of all stakeholders at the national level, including CAPFs, inter-agencies, civic bodies, state administration and other ministries, whether it's MHA, MAITI, Railways and many more. Operation Sindoor was the best example of tri-service synergy under clear-cut political directive and full freedom to act or respond.
The Defense Research and Development Organization has successfully flight tested the indigenously developed third-generation fire and forget man-portable anti-tank guided missile or MP-80GM against moving target at the KK ranges in Maharashtra's Ahilyanagar. The MP-80GM was tested against a moving tank target simulated using a thermal target system. The UK Ministry of Defence plans an $86.5 million midlife upgrade of its Titan and Thorjan armoured engineering fighting vehicles through a contract with Rheinmetall BAE Systems Land. The program is expected to run for up to 7 years, with vehicle upgrades extending into early 2030s. Germany has ordered 8 MQ-9B Sea Guardian unmanned aircraft system or UAS from General Atomics Aeronautical System to augment its fleet of manned Boeing P-8A Poseidon multi-mission maritime aircraft. The German military announced that deliveries will commence in year 2028. French Aerospace, Dassault Aviation and Harmattan AI have announced a strategic partnership to accelerate the integration of controlled autonomy and artificial intelligence technologies into combat aviation systems. As part of this collaboration, Dassault Aviation is leading Harmattan's AI's $200 million Series B funding round.
In a major leap towards next-generation warfare, India is quietly stepping into a rare and an elite club of military powers. The Armament Research and Development Establishment, or the ARDE, is developing a futuristic electromagnetic railgun. It's a weapon that fires projectiles not with gunpowder, but with raw electrical power. If operationalized, this technology could redefine long-range artillery, giving Indian Army a strike precision capability that relies purely on speed, mass and physics and not explosives. Let's break down what this means and why this project could be a game changer for India's battlefield doctrine.
The Consultative Committee of Ministry of Defence, headed by Raksha Mantri Shri Rajnath Singh, visited Armament Research and Development Establishment ARDE Pune, a premier laboratory of DRDO under the Aegis of Armament and Combat Engineering System Cluster on October 16th of 2025. There, the committee was apprised of the status of Railgun and other technologies being developed. So, how exactly does a Railgun work? And why is it being described as one of ARDE's most ambitious project till date? Why it is a leap in military technology? Unlike conventional artillery that uses chemical propellants to push a shell out of a barrel, a railgun operates on electromagnetic force. According to ARDE chief Mr. Ankati Raju, the system uses an immense electrical surge, nearly 11,000 volts and 2.5 mega amperes, to accelerate a solid projectile along conductive rails. This electromagnetic push generates enormous kinetic energy, launching the projectile at speeds of around 2000 meters per second, close to Mach 6. With this development, India joins a select group of nations, including the United States, China and Japan, that are actively pursuing operational railgun technology.
Speed is one thing, but real question is battlefield impact. What kind of firepower and range are we talking about?
The numbers are staggering. ARDE's railgun is designed to fire a 50-kilogram projectile to distances of nearly 200 kilometers, far beyond the reach of most conventional artillery systems. And there's a critical difference. This projectile carries no explosives. Destruction is achieved purely through kinetic energy, the sheer force of impact at hypersonic speed. This brings multiple advantages. Extended reach, a 200-kilometer strike envelope reshapes deep fire capability, logistics and safety, since no chemical propellants or explosive warheads to store or transport. Cost efficiency, solid metal projectiles are far cheaper than missile systems over sustained use. In essence, it's artillery that hits like a missile without being one.
But turning cutting-edge physics into battlefield-ready weapon is never easy. What are the challenges and how far is India from actual induction?
ARDE acknowledges that weaponizing a railgun is a complex long-term effort. The current focus is on integrating critical subsystems, high-power capacitor banks to generate and release massive electrical energy, advanced rail materials capable of surviving extreme heat, friction, and electromagnetic stress. Open source indicators suggest that this effort aligns with dedicated infrastructure like the Center for Electromagnetic Launch Technology, or the CE MALT, which aims to scale railgun power from 10 megajoules to 100 megajoules. According to ARDE leadership, key enabling technologies are already in place. The next phase is about durability, reliability, and battlefield integration. The projected timeline is somewhere within the next decade.
If successful, this railgun will not just be another weapon, it will be a strategic deterrent, a system that strikes at extreme range, at hypersonic speed, without explosives, and with reduced logistical burden. It fits perfectly into India's push for self-reliance and future warfare dominance. For the Indian Army, this could mean deeper reach, faster response, and decisive edge in high-intensity conflict. India has crossed a critical threshold in the race of hypersonic weapons. The Defense Research and Development Laboratory, a key laboratory of the Defense Research and Development Organization, has successfully conducted a long-duration ground test of actively cooled scramjet full-scale combustion. The test was conducted on January 9th of 2026 at DRDL's Advanced Scramjet Connect Pipe Test Facility, achieving a sustained runtime of over 12 minutes, a landmark achievement in hypersonic propulsion. This milestone quietly moves India closer to operational hypersonic missiles, the weapons that can travel at more than 5 times the speed of sound. But what exactly did India test and why does it matter so much?
To understand the importance of this breakthrough, we need to understand the engine at its heart, the scramjet. A scramjet, or a supersonic combustion ramjet, is fundamentally different from conventional jet engines. Unlike turbojets or rockets, a scramjet has no moving parts, draws oxygen directly from the atmosphere, burns fuel while air flows through the engine, remains supersonic. During the DRDL test, the combustor was actively cooled, a critical requirement because temperature at hypersonic speeds can exceed more than 1000 degrees Celsius. This can lead to equipment failure. Sustaining combustion for 12 minutes demonstrates that India has solved one of the hardest challenges in hypersonic flight, and that is thermal management and stable combustion at extreme speeds.
Scramjets are often confused with ramjets. Why are they different and why do they matter? I'll explain to you with the help of these diagrams on the video wall. This is a ramjet and over there is a scramjet. The basic difference is that ramjet propels the missile from Mach 3 to Mach 5. That is 3 times faster than the speed of sound to 5 times faster than the speed of sound, while the scramjet is a hypersonic engine which propels a missile beyond Mach 5. So this is the basic difference between these two engines. So how do these engines actually function? So let's try and understand. When we talk of ramjet, supersonic air enters the ramjet, it is slowed down, fuel is injected, ignition is carried out, and exhausts propel the missile at supersonic speed. Now here we have a cone in between this engine that you can see. This is the cone that slows down the airflow. The supersonic airflow coming slows down, ignition takes place, and exhausts go out, thus propelling the missile at Mach 3, Mach 5. Now, when we talk of scramjet, in scramjet, the speed of the air is not reduced. The hypersonic speed or the supersonic speed of the air continues to remain in that form. Ignition is carried out, fuel is injected, and the gases coming out are also at the same speed as the intake, that is hypersonic inflow and hypersonic outflow. So this is the basic difference between a scramjet and a ramjet, and that is why scramjet technology is very, very difficult to achieve, because it is something like in a hurricane you are trying to light a candle. So the airflow is hypersonic, you are carrying out ignition, which is the most toughest part, while in a ramjet it is not so, because you are slowing down the airflow, giving ignition, and then propelling the missile at the desired speed. So this is the basic difference between these two engines. Apart from this, people also confuse between a hypersonic glide vehicle and a hypersonic missile. So how is a hypersonic missile different from that of a hypersonic glide vehicle? This is a fantastic video wall that has been prepared by the team, which will explain to you the difference between a ballistic missile, a hypersonic glide vehicle, and a hypersonic cruise missile. So what we see here is a launch site and the target and the parabola where ballistic missile is written, and we have India's Agni missile. So this is the parabola of the ballistic missile. Ballistic missile is fired, it crosses the atmosphere into space, travels in space, does a re-entry and hits the target. Now let's talk about hypersonic glide vehicle. Hypersonic glide vehicle is mounted on a ballistic missile. So it is fired like a ballistic missile. It fires, it crosses the atmosphere, goes into space, and when it is on the top, points towards the target and releases the hypersonic glide vehicle. The hypersonic glide vehicle, because of the potential and the kinetic energy already achieved, it glides down, it accelerates further and hits the target. Now when we talk of hypersonic cruise missile, it is fired, it does not cross the Earth's atmosphere. It stays anywhere between 20 to 30 kilometers, travels along the Earth, basically parallel, and then hits the target. Now both the hypersonic glide vehicle is also maneuverable, but then it is gliding, it is not maneuverable to that extent, while that the hypersonic cruise missile is totally maneuverable like any other cruise missile. So this is the difference between the ballistic missile, hypersonic glide vehicle and the hypersonic cruise missile. Having understood the basic differences between a ramjet, scramjet, hypersonic glide vehicle and a hypersonic missile, let's qualify as to what does this DRDL test actually tell us about India's hypersonic roadmap. Why this test is a strategic breakthrough.
Sustaining scramjet combustion for over 12 minutes is a global benchmark achievement as it indicates maturity of indigenous scramjet design, readiness to transition from laboratory tests to flight trials, and a strong foundation for long-range maneuverable hypersonic strike weapons. Only a handful of nations, including the United States, China, and Russia, have demonstrated comparable capabilities. For India, this test signals a shift from experimental hypersonics to weapon-grade systems.
This scramjet breakthrough is not just about speed, it's about strategic credibility. Hypersonic cruise missiles powered by scramjet compresses decision-making timelines, thus evade existing missile defenses and redefine deterrence. With DRDL's successful long-duration test, India has taken a decisive step into that elite club. Why Pakistan is pushing the JF-17 in the Islamic world? Pakistan's aggressive push to sell the JF-17 Thunder is driven more by strategic necessity than technological confidence. At one level, it is about economic survival. Pakistan needs export orders to keep JF production line alive, earn foreign exchange, and justify decades of investment. The aircraft is marketed as affordable, sanction-resistant, and politically flexible, an option for countries shut out of Western fighters. At one level, it is about economic survival. Pakistan needs export orders to keep JF-17 production line alive, earn foreign exchange, and justify decades of investment. The aircraft is marketed as affordable, sanction-resistant, and politically flexible, an option for countries shut out of Western fighters. But the campaign is also geopolitical. Pakistan frames the JF-17 as a symbol of Islamic defense self-reliance, appealing to identity politics as much as the capability. This explains the focus on countries like Libya, where fragmented authority and arms embargo gray zones create demand for relatively low-cost combat aircrafts. Azerbaijan, where Pakistan leverages strong political military ties built around Armenia conflict, and Bangladesh, where Dhaka seeks affordable fleet replacement options while balancing relations with China, Pakistan, and India. The China factor is central. Backed by China, the JF-17 acts as the gateway platform, embedding Chinese-Pakistani training, maintenance, and logistics networks that can later expand influence. Regional implications are modest militarily. JF-17 does not shift air power balances against India. Politically, however, it expands China-Pakistan reach, lowers the threshold of fighter proliferation, and adds volatility in already fragile regions. The bottom line is that it is about relevance, influence, and survival, and not at all air superiority. That's all for this week on Defense Dynamics. Do share your comments on social media with #DDWithDanveer. See you next week with new defense and geopolitical developments and their analysis. Until then, goodbye and take care.